Okay, so here we're going to have a look at, given the equation x squared plus px plus q equals 0 has these roots, find an equation, and it should say find an equation in terms of p and q whose roots are alpha, alpha minus 1, beta, beta minus 1. Okay, so if we start, we know that x minus alpha, x minus beta is the factored form, because these are the roots of the given equation x squared plus px plus q. Okay? Oops, plus q should be an x. Okay, so then if we expand the left hand side, you will see that we get x squared minus beta x plus minus alpha x plus alpha beta equals the right hand side. And here we can collect our like terms on the left hand side, x squared plus, let's say, minus beta minus alpha x plus alpha beta equals the right hand side. And from here you can see, therefore, p is equal to minus alpha plus beta, and q is equal to alpha beta. Okay, we're going to need to use this information later on. So we set up the second part. We know that the roots are x minus alpha, alpha minus 1, and x minus beta, beta minus 1. Okay? So expanding this expression, and anytime we see something like this or this, we can make a substitution. So x squared, then minus beta, beta minus 1, x minus alpha, alpha minus 1, x, and then plus alpha beta, alpha minus 1, beta minus 1. Okay, I'm running out of room on the, I'll just try to make my screen a bit bigger here. Okay. So, from here, we want to start looking for some things that we can use this information. Okay? So, let's take it and rewrite minus beta, beta minus 1, and minus alpha, alpha minus 1 by collecting our like terms. And here you can see plus alpha beta is a q. Okay, and expanding these brackets, you get alpha beta minus alpha minus beta plus 1. Oops, ran out of screen. Okay, excellent. And here again, you can see an alpha beta, which is a q, and here minus alpha minus beta, which is p. Okay, so the furthest bit over here, q, q plus p plus 1. Okay, then let's deal with this ugly mess in the middle. Alright, so I would suggest that we take it, expand the inside a bit more, plus minus beta squared plus beta plus alpha squared plus alpha x, oops, there we go. Okay, so this is what we have at the moment. Okay, so you can notice here that this is going to be a minus p, but we have a problem because of this here. So this and this we can't do anything with quite yet. So we need to make a tricky step here. Let's see, expand my page a bit. Okay, so if we take minus alpha plus beta, we square that, it gives us minus alpha squared plus 2 alpha beta plus beta squared. Okay, now that is not what we're after, right? So what you need, what I need, fix this. This of course should be negative. Okay, so what I need is to think about how can I get this to be equivalent to this piece. So I've got minus alpha squared minus beta squared, but I have an extra minus 2 alpha beta. So in order to make it equivalent, I need to add 2 alpha beta. Okay? So now we're allowed to write this. X squared minus alpha plus beta squared plus 2 alpha beta minus p. And the minus p comes from this here. Plus b plus alpha, and up above, that was of course here. Okay? Alright. So this piece of the puzzle, I guess let's leave that out for now. This piece of the puzzle here could be written as minus p squared, and this piece is now 2q, and this is minus p. Okay? So negative squared becomes positive, and therefore all together at the end of the day you get x squared minus p squared plus 2q minus p x, and on the right hand side we had plus q plus p plus 1. Okay, and that brings us to the end of that problem, number 5.